Hello guys, welcome to the Docker course. So in this video series we will learn about Docker. We know that Docker has become something very mandatory and important tools for each and every developer. So especially after the rise of microservice based application and the launch of Kubernetes, Docker has become very crucial to learn each and every developer. Just like Git, without Git you cannot do anything in any organization. Similarly, Docker has become similar like Git. It has become something very basic and fundamental tool you need to learn. So Docker is very easy to learn. So this video series will be just mastering Docker. Let us understand the concept of Docker from this image. So you are seeing in this image there is a sieve and which is carrying a number of containers. Okay, so by having these containers, what advantage we get is that we can carry different categories of goods very easily. So say for example, this first container is carrying some frozen foods, the second one say it is carrying some electronics item, and third one say glass items which are very much fragile. So now you see that frozen foods require a temperature controlled environment inside the container, otherwise your foods will be wasted. Okay, similarly say for example electronics goods will require a low humid weather, and for the glass item you will need to put some soft materials so that it does not break. So you are seeing that the different categories require different kind of environment to keep them okay. So by having this container we can easily maintain that environment. So you are seeing that this is a very important term, just remember this environment. Okay, and another thing we get that the container 1 does not interrupt container 2, so they are completely isolated. So this is also very important term, just remember this is the isolation. The container gives us this isolation facility. And also another thing is that portability. So when you are offloading this container from the ship to say for example any other vehicle or any other ship, so it becomes very easy when there is container, because you will just the required environment for each of these items are already present inside that container, so you do not need to worry at all. So these three terms, the environment, isolation and portability, this is provided us by these containers. Now let us compare this image with our computer world. So say for example this ship is our computer, and the deck here, that is the operating system, that is the host operating system, and the containers are the different softwares and tools we want to install in our computer. So if there is no container, so what happens, we directly install softwares into our host operating system, and sometimes we face problems like this, that say software 1 is not compatible with software 2, and it becomes difficult for us to install software there because of these compatibility issues. Okay, and also say for example our host operating system is Windows and there is some software we want to run on Linux, so it becomes difficult for us to do that. Also sometimes it becomes difficult for us to maintain the multiple version of a single software in our machine. So say for example you want to install multiple version of Python, either you need to take help from some special tools like Anaconda, etc., or sometimes it becomes impossible for you to do that for certain set of softwares. Okay, so now say for example there is some tools which gives us this facility of containerization. Okay, then it will be very easy for us to do this kind of problems, to mitigate this kind of problems. So Docker exactly does that same. Docker is a containerization platform. Just you are seeing exactly the way in this sieve, you are seeing this container gives us a number of facilities like isolation, environment and portability. So Docker creates container on top of our operating system, and then inside that container we install our softwares and applications, etc. So Docker gives us that facility. So by having that facility you are seeing that we solves a number of problems. So there are a few very general and common problems we face in our daily life, is that when we do a development of any application, we develop it in our local machine generally, and when we deploy it, the deployment server most of the cases becomes Linux and sometimes Windows also, but in most cases it is a Linux operating system we prefer to install our application to run in production staging. So what happens, there is a difference, there is a gap between your development environment and your runtime environment in production. So we see surprises sometimes, that we say that our application is running in local, but when I am deploying in staging on production it is not working. So these kind of problems we generally face. But if there is container, we can easily mitigate that problems, because Docker gives us the same environment where we develop and where we application, because Docker helps us to package our application, our libraries, and our dependencies, and the runtime environment, that is the operating system also. It packages together all of these things. It's packaged together and we can save them, just like we are doing here, that all the runtime environments, our application, the goods and their environment, everything we are just packaging together inside a container and shipping it. Similarly, Docker helps us with that. We do not need to worry at all about the runtime environment and its dependencies. Okay, so that is provided by Docker. So another thing is that, another problem we generally face is that, say in our team there are different team members are using different operating system for doing development. So Docker helps us to provide them a uniform development environment. Otherwise, what you have to do is that you need to go each and everyone's machine and do configure for the runtime environment for different OS. For, say for example, Mac, Linux or Windows, the configuration and settings becomes difficult and challenging sometimes. So Docker helps to mitigate that problems as well. And I already was told about the multiple version of a single software, and the most important part is that deployment of application. So you developed it, and that if you just create a deployment pipeline there by using, say, Jenkins or Cloud Build, something like that, there are many tools are there. So if there is Docker, it is very easy, it becomes very easy to deploy that application from your local to the production or staging servers. Okay, so and also it helps us to create scalable application. Okay, so you have heard about the horizontal scale, I think. So when you are just replicating a single instance of your application to multiple, the scalability, that is downscaling, upscaling, become very easy when there is container. Okay, so we will come later to those things to discuss later. So just for example, understand that the Docker helps us to package together a number of things, like the application source code, its libraries and dependencies, and the runtime environment, means the operating system, architecture, etc. Everything it can merge and combine together in a package. You can easily transport it from your local through network or any other medium. It is very easy. So as Docker is a lightweight virtualization platform, let us see some of the differences between virtual machine and Docker. So here we can see that in case of virtual machine, what happens. So first there is a hardware, and on top of that you install some host operating system, and there after that there is some software like VirtualBox, VMware, etc. So though this host operating system is not mandatory, you can directly install some hypervisor software on top of hardware directly. So now what happens, VMware, what does it do? It just allocates some portion of this hardware to create virtual machines. So say for example, you have a 32 gigs of memory or 8 core CPU, and you create a new virtual machine with, say for example, 8 gigs of memory, and allocates 2 core of CPU to this virtual machine. Okay, so here what is happening, from a larger size of hardware, you are creating smaller size machine, and on top of that machine you can install any operating system there as per your requirement. Okay, so mainly VMware or virtual machine used to create virtual machine, though the hardware is same, but you can create multiple machines out of the same hardware. Okay, so this is mainly used for creation of servers, and when you are testing something, you have certain operating system in your laptop or computer, but you want some other operating system without just interrupting the host operating system. So some kind of, as it provides a complete isolation and complete security, etc. So you can test anything which you are feeling like insecure or virus testing, etc. you are doing. Okay, so or you have, say for example, a single machine, you want multiple VMs to test something with multiple VMs, say you are creating a cluster of Elasticsearch or something like this. In that cases, so VMwares are useful. Okay, so here how Docker works is, so first you have the hardware and then a host operating system, and then on top of that you install Docker engine. Okay, and now Docker engine helps to create your container like this with a certain runtime environment.
a certain operating system flavor. Okay, it's host operating system, it's required binaries, okay, and dependencies, configs, etc. All these things are packaged together inside this application. So the main difference between VirtualBox and Docker is that Docker works at the application layer and it virtualizes the operating system. Your host operating system is, say for example, Windows or some other version of Linux distro, but your application sees it as Ubuntu. The main difference is that these are very lightweight virtualization, lightweight package. Here only the Ubuntu file system and some specific binaries remains there. No operating system kernel present here in these boxes. Okay, but here in this case, when you are creating a virtual machine, a full-fledged operating system is installed in this hardware. Here what happens, you have a complete kernel here, kernel operating system of this Ubuntu kernel. Okay, so when there is an app, for example here, it requires some hardware resource. It talks to this kernel first, and then the request goes to this, from this kernel to this hardware. Okay, this way it goes. And the host operating system kernel is not involved here. So here is the host operating system kernel. It has no role here. This does not do anything for this particular use case. But here in case of, say for example, Docker, here your application source code is running here, say for example here, and it requires some set of hardware requirement. Then it talks to the kernel of this host operating system. So here the host operating system kernel present, that I need some hardware resource. So it talks to this kernel, and this kernel then talks to the hardware. Okay, so this way it works. So only what this is very lightweight, only the Ubuntu packages, file system and some specific binaries it contains, but here it is a complete full-fledged operating system. So that is why what happens, so when you are starting a VM, it takes a larger amount of time because it loads the entire kernel, just like a operating system boots up. Similarly it happens. But in case of Docker, what happens, it does not load any kernel operating system. Already your host operating system is running, and you just spin up this Docker container, and it leverages the kernel of this host operating system. Okay, so this virtual machine and Docker, they are not competitor to each other. They are great at their own use cases. So mainly these virtual boxes, VMware, these hypervisor softwares, they are used to create virtual machines. Like in case of, say, cloud technology, they are used to create virtual machines. Like in AWS, you are creating EC2 instances. In Google Cloud, you are creating GKE instances, etc. Okay, and also other cases like for testing, when you need a complete isolation kind of thing, then you will create some virtual machine and do testing, etc. for your local use cases. But in case of the Docker, main use case for this is that for the management of your application, easy deployment of your application, creating a scalable application, because your container is very easily replicatable. You can replicate this container easily. But here in VMware, that is not the intended use case, so it is a bit difficult. But the main use case for this container is to replicate, that you can scale down, scale up accordingly. In microservice based application, you know, when you are creating a scalable application, you need to scale up and scale down quickly. So these are the main use case for Docker. Let us see different components of Docker. So the main component of Docker is this Docker D, that is called Docker daemon. So when you install Docker in your machine, so this is the portion of software which is installed in our system. So this is the brain of Docker, you can call. And along with this, there is another component which is installed is Docker CLI, a command line interface. Okay, so these two things communicates through HTTP. So there remains a Docker socket. Through that socket, Docker CLI communicates to Docker engine. And Docker CLI is the command line tool by which we can interact to Docker engine. Okay, so means after installing a Docker, we will get a Docker command in our terminal. So this is the main two components of Docker. And the other terminologies we need to be familiar with is that most important is the Docker image. Docker image is a static read-only file, just like operating system ISO images. So when you download operating system from website, say Windows or Linux, so you create a ISO file there, or dev package or DMG package like this. Okay, so means we can think of it just like a zip file also, where you are packaging a number of things together and generating a single file. So Docker file is also the snapshot of the Docker image. That is, we already know that Docker packages a number of things together. That's your application source code, configurations, libraries, and their runtime environment, everything it packaged together, and it generates a single file like this. That is called Docker image. Okay, and so other component which is very much important is that Docker container. Docker container is the tool which we expect to create. That is the main objective of Docker, just creating a container. Now here Docker image is a static file. Okay, it does not run, it just resides in your file system. But Docker container is something which is a living entity. Docker image works as a template to create container. So if we just compare with the object oriented programming, we can think of image as a class. That is, a class works like a template, and object we create from class. So this is just, we can just do a comparison with this, that image is like class, or container is like object. From a single image we can create multiple container. Container runs as a process in your host machine. So this is a running entity, and it has its life cycle. There is running, stopped, paused, this kind of states it has. The other important component is that called Docker registry. So Docker registry is a cloud-based registry. This is a public website or private website, it can be. By default, Docker registry is the Docker hub, that is hub.docker.com. okay, that's just public website. You can think of just like a GitHub. So in GitHub, what we do, we just push our source codes, and other team members, they can pull and download and do activities, etc. So similarly, Docker registry is also something like this, where we can create our own images and push it to the registry, or there are public images available. We can download those images by pulling them. Okay, so whatever the software packages we need, for example MySQL, Python, or Node.js, okay, or say for example MongoDB, Redis, everything, all the official images are present here in this Docker registry, I mean hub.docker.com. So the companies publish their official images and push them to this public registry, and we can download them freely. Okay, if we have internet connection in our machine, then we can just run a single command and download those images and create container from them. So these are the main components. So what happens at the in our machine, after installing Docker daemon and Docker CLI, we run some command in Docker CLI, we pull some image from this registry, and this image, from this image we run again some other command. By using those command, we can create Docker container, and after the container is created, we can use them as per our requirement. Okay, these are the main components of Docker. There are a few other components also, we'll learn them one by one, but these are the very fundamental and basic components we must know before starting to the practical section of this Docker. To install Docker in your local machine, type here in Google the Docker install. So it will land you into this page. So from here go to there, and then as per your operating system, click here. So in my case it is Linux, so I am clicking on Linux. So here you will get, this is Docker desktop installation, means if you are installing Docker in your local machine where there is a graphical user interface, then just click on this Linux desktop option. Okay, so for this, as per your OS, download that specific file. You can download it from here also, install on Ubuntu. If you just click here, it will land you to the specific Ubuntu related page. So it is the dev package. From here you will get the Debian package will be downloaded. After that, these are the installation steps you need to follow. Okay, and I think after that, how to start the service, and enable a certain user. Okay, all these options are given here. Just follow this documentation, they are very clear. So this is for Linux, and for Windows, just in the Docker desktop section, click on Windows. You will get the Windows option here. The file will be downloaded after clicking on this link, and the steps we need to follow, these are the installation steps. Just follow these steps here. So you will get a graphical user interface just to follow that steps to install, and after that you can start it from here and use. Okay, and for Mac also you will get the similar kind of link here. So just for Mac there are two kind of, I think, architecture, the Silicon chip and the Intel chip they are using. So just as per your hardware, just download the specific one, and then also follow the steps to do that. And if you want to install Docker in your server, Linux server for example, where there is no graphical user interface, just follow this, then click on this Docker engine link, and you will get the different operating system options here. So for example, if you are going with Ubuntu, then this is not desktop, you can see this is Docker engine installation. So you can do this in your local machine also. In Linux, if it is a Linux machine, you can follow this also, this will also works. And so for doing this installation method, go to the installation method section, and there are steps. Step 1 is this. So you just copy these commands and run it in your terminal, and after it's done, just do this. I think that's all. And after that, just to test your installation is successful or not, you need to run this command. Okay, cool, we are done. So let us, in our next section, see few of the important Docker commands. So now let us learn few of the very important Docker commands. So first thing we'll be doing is that we need to download an image. Okay, to create a container we need to download the image. So say for example you want to install Redis in our system. So I'll go to Google first, and then I will do a search Docker Redis. So Docker Redis, that will land us to this Docker Hub link. Okay, you can see Redis official image link is this. So I'll visit it. So here in this page you can see this command. This is the docker pull redis command by which you can download Redis latest image in your local machine. So I'll copy this first and I'll paste it here. Okay, docker pull redis. I'll run this. So you can see it's using default tag latest. I mean, if you do not mention any version here, it will download the latest version. You can see there are some layers which are getting downloaded layer wise. As Docker images are created by layer, so actually there remains the base image first, and on top of that there are some changes, a new layer created, and on other changes there is another layer created this way. So when it downloads the image, it uses that layer approach only. Okay, so the image has been downloaded. So the next command we will see is that what are the images exist in our local machine. To check that, you need to run docker images. Okay, so by running this, you can see there is one image downloaded. One is image name is Redis, tag means is a version, some image ID and size, etc. Okay, so now next thing is that to check if there is any running container exist in our system or not. Okay, I'll clean this screen. So checking if there is existing container in our system is not, is this docker ps. So docker ps shows you if there is any container running. So you can see there is no container currently. Okay, so we will create a container from Redis image. So I'll just run this docker images. So this is the image details. So now I'll run this command. This is very important command, docker run. Then you will just put the image name docker and Redis. Okay, this is enough. I'll run it. Yeah, you can see one container has been created and it says that ready to accept connection TCP. So Redis is running now. Now the running in standalone mode, and at this port it's listening. So now you can see one thing, that this terminal has been occupied by this command. Okay, until you will not be able to do anything in this terminal. So let us open a new terminal. So here if you run this command again, docker ps, so So we will be able to see there is a container. Earlier there was no container, but there is a new container has been created. Okay, so now Redis is running in our system. Now this thing, the problem is this, you cannot stop this terminal. So if you stop this terminal with Control C or something, then your container will also be stopped. So this way running a container is called attached mode, means it will be attaching to this terminal only. So let us stop this. So I will Control C it. So there is another option by which you can run. So you can see here that if you just run docker ps again, you will see there is no container again. Okay, so earlier there was one container, but here docker ps will show no container because we have stopped the terminal, so the container has been stopped. So let us create it in a detached mode. So detached mode means you run put a -d here just. Okay, and also you can see another thing is that here in the container you are seeing there is a name was given. This is random name. Okay, but we can, if you want our specific, if you want to give some specific name to this container, you can create that also. Let us give some name also. Name Redis container 1, say for example. Okay, so let us run it. This time it returns only an ID. So this is the container ID. So now also the terminal is free now. We can run anything. We can run docker ps command here now. The docker ps now shows us that one container is running. You can see that this first part of this ID matched with this container ID. Okay, so now Redis is running in a detached mode, means it is running in the background, so we can use this terminal. Let us clear this. So now docker ps. Okay, so now if you want to access this Redis, okay, that how it is possible. One thing you are seeing that here the particular port here the Redis is listening to, it is 6379. But one problem is that Redis, when it runs, it actually runs in a different network. It does not run in the same network with your host machine. So this port actually is not the port of your host machine. So you will not be able to access this particular port with localhost. Localhost :6379. Actually this means the 6379 port of our laptop. Okay, but this port is not meaning that. So this port actually is the port of the container, which the inside the container it is listening this port. So there is only one command available to access this particular container, is that docker exec. By this you can execute any command inside the container. Okay, this command is very much useful to access into the container, and it is also useful for debugging purposes also. Okay, so now let us get into this container and see what is happening there, whether Redis is actually running or not. Parameter here -it mean it will give you an interactive terminal. Then I will put the container ID, and then you can put any command which you want to run inside the container. I want to run bash command. I want to get into the bash shell of the container. Okay, so you can see the prompt change. So currently it is, earlier it was learning being means my laptop, okay, prompt, and now I am accessed into the container. So this is root container ID, means root user. I have accessed as a root user into the container. Now the file system you are seeing /data. This is the container file system. Inside the container I am now. Now if you want to see that whether Redis is running or not, so you can see here by running the Redis CLI command. So Redis CLI will access into your Redis prompt. Okay, so you can see that we are in the Redis prompt. Redis is running. If we just check here info, you will be able to see all the Redis information. Okay, Redis is running as a master role. Okay, all this information are available. If you want to set any key in Redis, set x some value 100, set y some value 200. Okay, and say for example you do bg set here, you saved it in the disk. This way you can do any activities. Means Redis is running, but this is not accessible from the outside world. We are inside the container now, so that's why you are able to access. If you just run here lsl, you will be able to see there is a file has been created, dump.rdb, because we just ran the bgsep command here. So it has written the data whichever there x and y. that is written into the disk. So this file system which you are seeing here is the container file system. So I'll just get out of this container now. Control D or log out or exit will help. Okay, cool. Now we are back to the laptop terminal. Clear. So let us run docker ps once again. So docker ps shows you the running container. Okay, so another important interesting thing is that we know that only if some application is running in a certain port, you cannot run any other application in that port. But here you are seeing that as Redis is currently running in 6379 port, let us try to create another container. Okay, so I'll create one. Docker run, what was the option? -d detach mode, dash name is the Redis container 2, and I'll put the Redis image. So let us run it. What happens? So it will create another container. You can see the ID is different. So we'll run docker ps here once again. So you can see there are two containers running and both are listening to the 6379 port. So the reason there is no conflict, because every time a container is created, it runs in a different isolated network. So that is why this is the port inside the container. Okay, so inside the container you cannot run any other process in this particular port, but in your host machine you can run any number of containers with the same port, because this port is not your host machine's port. Okay, cool. So let us move ahead. So I'll show you how to just map a particular port, because these containers are not accessible from the outside world, okay, until you are doing docker exec and getting into that container and then doing anything. But that is not a practical use case, right? When you are using Redis, you will some of your application, that is maybe your Python application or Java application, that will be interacting with Redis. So that is running not inside this container, that will be run somewhere, some other places, right? That maybe that is a different container, or in some other environment it is running in a VM or somewhere. So that is why to access this particular container from the outside world, you need to do a port mapping. Okay, so let us do that. So I'll just clear this. So docker run. So to do that, docker run -d was the dash mode, dash name is the name I'll put, Redis container say 3 I'll name it, and then there is option called p. Dash p means port mapping. Then first port you are giving is that, say for example 6000, and then the next port is 6379. Okay, so the first port is your host port, means your laptop or your server machine's port, and the next port is the container port, and then whatever you are asking is the Redis image name, Redis latest is not mandatory if it is the latest version, and if it is other version you need to mention that version this way. So now let's run this. What happens? Okay, so this time you can see there is a new container has been created again. So I'll just do docker ps again. Okay, so I'll just zoom out a little bit just to make it look good. Yeah, so you can see the container 3, it is running. Earlier those containers are also running. I have not stopped or removed them, but every time you create a run, you execute this run command, it will create a new container. Okay, so here only difference you can see is that earlier it was listening to 6379 inside the container, but here you can see now that there is a container port which is mapped to 6000 port of our local machine. Okay, so now this is the local machine of our, this particular 6000 port is our local machine port. Yeah, so just to verify that, let's try to run the same command again with a different container name. So container 4, say for example you are going to create, but the port, the host port we will keep is 6000. If we run it, we'll see there is a conflict, because this particular 6000 port is occupied. Okay, right? So you can see the error response, bind for 6000 is failed, port is already allocated, right? Cool. So what we need to do, we need to just change this particular port, but the inside the container port, that remains same all the time, because container is there inside a separate network, there is no conflict. So I will make it 6001 and I will run Redis here. Sorry, so there is a conflict also again with the container name, because this particular container was created but it failed with the container 4 name. So I'll just update the name here. So container 4, I will make it container 5. Yeah, this time it's successfully created. We'll run the docker ps command here. Docker ps will show you there is another container 5, Redis container 5, which is running and listening to the 6005 port. Now we'll be able to access both of these Redis. This particular Redis will be able to access through our server IP or your local machine IP colon this 6001 port from any other any outside world. Okay, cool. So now let us move ahead. So I'll now show you how to stop these containers. So stopping container is very simple. So I'll just first stop this container, docker stop container ID. This will stop this particular container. So I'll run docker ps command. You can see that particular container has gone from here, and I'll stop all others. You can do this by using a docker container name also, docker stop this. So only 2 containers are running now. Okay, so to see the stopped containers, there is another option. So for example, there is another command called docker freeze all. So this will show you all the containers which are running and as well as which are stopped. So you can see the status here. So this is up for 2 seconds and this is just in its created state. So this was the failed one, right? You remember this, which there was a port conflict. So this was just created but didn't never run. So this was the running container and this is the running container. All 3 are exited. So if you want to run this particular container which was successfully created, that's Redis container 1. So you can run it. So to that you just copy docker start this. This will start your container. So if you just run docker ps, only ps without all options, so you will be able to see that container. Particular container, this container is also now running. Yeah, so we have run a number of commands now so far. One is the docker pull to download image from the docker hub. Okay, next is the docker run. Docker run is to create new container. So if certain image is not present in your local machine but you are trying to run, so for example you want to run docker run Redis some version, say for example 5.0 version. Just to ensure that particular image exists, you need to ensure it from this official image page of docker Redis. So you will go to this tags section. Tags will show you all the history of the version. So here you can see there are options. Docker pull Redis latest is a version. There are some other book 1 version, etc. Alpine 3.2 version, etc. So similarly you can just search a particular version if you are looking for. So 5.0 I will search. So here you can see that 5.0.14 is there. I hope this is also this. I think this will be downloaded if you run this particular command 5.0. So let us run this. So docker run will pull the image as well as I will create the image container. So unable to find image this locally, you will first look for in your local file system, but it's not there. So it's downloading. That's downloaded and it will run now. Yeah, you can see it's ready to accept connection and it's running. So if you now just as we have not given any -d -it option, so that's why it's in attach mode, and also it will pick some random name and there is no port mapping we have done. Okay, so just to show you that how actually this works, so I'll just check from here. So docker ps now will show you this container also. You can see that this is the new container has been created with 5.0 images. So another important thing, you can see that we are running 2 parallel Redis version in the same machine. There is no conflict, there is no problem. We know that Docker helps us to run multiple versions of a particular software in parallel without any hassles. So that is why you can see that Redis 5 version and the latest version both are running in parallel without any issues. Cool. So Docker run we know, then we know Docker start mean there is a stopped container, you can start it by using this, and Docker stop is to stop a container which is in running state, and Docker exec is a very important command by which you can get into Docker container file system, and there you can run Docker. Inside you can do some debugging, etc. Whatever commands you want to run there, you will be available, but inside the container there is a very limited set of commands available. If you want to install any particular command, you can do that inside the container. Docker logs. So if you want to see the logs of a particular container, say a particular container is failing for some for some reason, so if you want to check the log, you can see this Docker logs. Then you can put the container ID or container name. You will be able to see what are the different logs, errors, etc. You can see it from here. So these are the few of the very important and fundamental Docker commands. Okay, we need to know, and after that in our next sections we will learn about the some advanced thing like Docker file, okay, Docker network, Docker volumes, etc. Okay, cool. Thanks for being with me.